Hi everyone. Welcome to my talk about how to be tough application in 2016 and what Lagom is. Now, I was accidentally put into programming languages. So people who expect Lagom to be another programming language, unfortunately, I'm going to um, disappoint you. So Lagom is a framework. But as things go, hopefully you will enjoy my talk nonetheless. So let's start. By the way, my name is Katrin Shechtman and I'm from Lightband. So before we actually start getting serious, I'd like to introduce a small game. And it will be trying not to take the beaten path, where we will talk a lot about monoliths and how microservices are awesome and what we should do about it. So the game will be actually something that we experience every day at our work. The game is to develop a successful modern application. It's actually an excellent gamification engine, because every time when we come to work, we take our bets about what kind of technologies we are going to employ next. And who knows, maybe next year we will have to rewrite it because we didn't make the right bet. So requirements are, of course, we are going to have millions of users and billions of requests. There should be real-time performance because people need to know about the statuses of their friends right away and about the books that they need to read next, even better yesterday. And of course, we have to have rapid delivery because business demands and because there is a lot of competition. And if competitors come with a new feature before us, we are screwed. So, about goals, your role, and what's the system. So game is, the goal of the game is how to fail this project, okay? So please remember, when we go through the game, it will be, your role will be playing the devil, trying to make your teammates to fail this project, okay? Get into this mindset and try to bear with me here. Now, a little bit about rules. So every level, we are not going to have too many before we will have to get serious. Every level, you've been given a task, and you need to figure out how to do it best, so because you want to win. Upon successful completion of each level, we are going to have an achievement, which is going to be unlocked, right? It's very standard path of game. That's what I heard. And at each level, your teammates actually are very similar to the real world scenario. They become smarter. They learn on their mistakes. So with each level, it's going to be harder and harder. And also, whatever you achieve each level might be erased because your teammates learn on their mistakes. So do you ready? Are you ready? Okay. So level number 1, you have to prevent code isolation in your code base. Okay, how you can do it? So you're trying to, first of all, we are going to have cheat codes throughout our game. So whoever doesn't know how to prevent code isolation, actually the easiest path to take is to create org whatever your org is .common. Soon enough, your teammates will start committing new code that they think that it's shared. They will be very, very happy as puppies to put their code, to collaborate on it, and not to have to write it twice. And if your teammates are a little bit more experienced, they might say, no, wait, we do want some code isolation. You can say, you can try to hide the issue by making them excited about new tools that they can use. For example, let's ask the question whether it's GitHub Flow versus Git Flow, right? So they don't pay attention to what they're doing, but more about how they do it. Now, let's say there is no code isolation in your project. So what's the achievement? Soon enough, your very happy teammates that behave like a puppy becomes pack of wolves, and they spend majority of their times actually fighting who broke the build and who introduced the latest conflict in this data, in this code set. So you basically get code monoliths, okay? The problem is it's 2016, and your teammates, as we said, are smart. So what they do, they actually figure it out, and they start isolating their code. So let's go to level number 2. Let's try to prevent data isolation. let's make everyone come to the same database, to the same schema, to the same whatever data is involved, right? So cheat code here will be global, right? Once we hear global schema, we're probably on the right path to fail this project. Now, the problem is that it's 2016 and our teammates are smart. So what they figure out that they don't want to participate in this happy party when everyone gets piece of the data. And even if you make sure that everyone gets a global access and can make changes to the schema, they start figuring it out. Why they start figuring out? Because they are tired to participate in postmortems. Once you achieve the level of competency to fail your project as data monolith, actually, once again, the postmortems look like nothing works, and not everyone exactly, or no one exactly knows who changed the schema last. And here, in postmortem, people usually don't fight. They more like, it was not me, I'm sorry, it was not me, okay? So data monoliths, but they are smart. They overcome this one as well. Level number 3. This one I like the most because it's really an interesting one. So what you need to do next is to prevent the real componentization and distribution of your things, right? So you have your application and access to, you don't have global schema anymore, but you still have your kind of application. And the question is how you put it together in terms of components and what kind of deployment you're going to employ. Now, your teammates know how to read, and they spend a lot of time, mostly at work, by reading other people's articles. They heard about Docker, they heard about virtualization, they heard about all the cool stuff, even maybe Ansible. So what you need to do also to become smarter and trickier in how you want to fill this project. You can tell them, okay, you have your application, don't change a thing, just put it in container. You got your Docker, and you're also on your right path to fill your project. If your teammates are not bought into this idea, you can tell them maybe whatever big servers or big components that or third-party components that we have as kind of our underlying deployment, we could use tools that actually embed those components. So we don't see it, but it still hurts. But your teammates figured out that actually it's a skyrocketing budget. It's because if you take something big and you're trying to squeeze to something small, what will happen? You will pay the price, right? And more and more teams are responsible for their own budgets. And when it happens, it hurts because no one wants to pay for something that they didn't use. Now, level number 4. You can tell them, wait, okay, so fine, we divided our schema and we have different tables for everyone, but we don't want to have different database servers. We can put on the same database service. Why not? We've been doing it for ages. Now, the way that you can sell it for them, it's actually to make sure that you're using a reputable database that is very known, is very enterprisey. It should be industry leading, otherwise it won't fly. It should simplify the access and make everything just easy. So, but make sure that it's big, right? And the idea is that once it's big, you start getting your bottleneck in the project as access to your data, even if it's different tables, and you're kind of set on your path to success of filling this project. So the achievement that you get is, you can see, it's actually distributed monolith. You're having this pile of your data, and actually this animal that I'm not sure how it's called in English, it's not any big horse or any big dog anymore. And of course, DevOps might be kind of happy, but also they're kind of sad because they have to maintain it and they get a lot of complaints. Now, we are getting to a level which is actually level pro, the professional level. So let's give a little bit of background to this level. First of all, your team went through all these levels successfully, unlike you, and they absorbed the idea of microservices. So they don't want to hear about monoliths versus microservices anymore. Anyone who mentions it at a water cooler, he's not cool anymore. He's like, he was cool yesterday, he's not cool anymore, because everyone gets it. Everyone read Martin Fuller, everyone understands code isolation, every microservice alone, every microservice has its own database, they own their own data. So far, so good. So does it mean that you failed to fail your project? Does it mean that there is no other way around in this game? What do you think? There is or there is not? That's it? You're on path to success? No? Okay, why not?
The microservice structure to integrate all this gets the complexity.
Very good. But we will get there. Your teammates are actually even smarter than you could think of them. They also not only they understand CAP theorem, they understand the extension of CAP theorem, which is PACLC theorem. And when CAP theorem talked about what happens if you have network partition, if that you have to choose between consistency and availability, this theorem talking about wait. Okay, we know already that when network partitioning happens, consistency or availability, you cannot have them both. But what happens if there is no partition? There is still choice to make. And the choice should be between consistency and latency. It makes sense, right? So if you want really, really low latency, you can't wait till make sure that your distributed transaction succeeded. So you have to take your bet and choices, or maybe to implement some kind of looking ahead and hoping that it will be a good optimistic approach, right? Okay, so your teammates get it. Okay, that's great. The last but not the least, and let's spend some of our time here on this slide, because this slide is one of the most important slides in our game. Maybe not the funniest, but probably the most important. So what your team understands as well, it's what's so-called reactive principles. Now, reactive principles were kind of underdog 2 years ago, maybe even 1 year ago. But now, if you go and look around on the internet, everyone seems to be reactive. And it's interesting that how sometimes people assume that they don't have to do anything different for getting different results. But we will get there a little bit later. So what do we see here? When you want to have a successful or failed project in this sense, there are 4 things in software projects that are really important. First of all, project goals. Okay, and we as software developers tend to start from architecture. I almost did it now because I wanted to start out from architecture as well, but then I made pause and I remembered that I want to start from project goals. The project goals are not responsiveness and not elasticity and even not rapid delivery. The project goals are user experience and cost efficiency. That's what makes project successful, or it make it a failed project. It make it a failure. Now, how this user experience or cost efficiency can be supported? They can be supported partially technically by having rapid delivery. So you have your code isolation, so every team is responsible for their microservice, so they can deliver their features independent from other teams. Responsiveness. Of course, you can have the best application in the world, but if someone nowadays has to wait a minute or 30 seconds or even 15 seconds for results to come, they will go to competitors, even if they have less features. We became very, very impatient about things that we want to get. We even don't care about whether the internet is low. We want it here and we want it now. So your responsiveness should be super, super high. And of course, elasticity. So elasticity, it's something that people tend to exchange between, replace elasticity and scalability. It's almost the same. So elasticity, it's like scalability, but when you can, not only you can shrink, you can go up, but also you can go down. So you can shrink and grow, both, right? Now, everything that I just said, it's actually relies on being able to isolate. Isolate all the things, whether those are errors, those are components, it is code, whatever. You have to isolate to be able to get to this level of delivery, responsiveness, or elasticity. Now, the blue boxes are a little bit trickier. They're trickier because we are talking about architecture. And with the rise of agile, architecture took a hit. Nowadays, and it's a little bit coming back in circle, because nowadays we want to create a project and run with it, and only when we see that it doesn't work, maybe to adjust it and make changes. It's a little bit problematic when we are talking about distributed systems, because you need to think upfront what kind of characteristics you want your system to have. Otherwise, you don't end up with distributed system, but you actually end up with monoliths, which is totally not scalable. And resilience and scalability is actually two characteristics that can be clearly identified and clearly put. Either your project has them or it doesn't have them. There is no, I have them partially. So it's either scalable or it is not. It's either resilient or it is not. In terms of architecture, I mean, of course, code will always follow and it will take time to get there. Now, in order to get resilience and scalability, there is no other way around, and I'm being arrogant here. There is no other way around but being message-driven and asynchronous. Because if you're not message-driven, it means that you're kind of something else. What else could it be? It's kind of synchronous. It doesn't matter whether, technically speaking, you do HTTP or UDP or TCP or whatever, I don't know, gRPC, when you don't care what it actually does. It doesn't matter. As long as your components are not isolated in a way that actually only can exchange messages, that gives you additional resilience and scalability. And if you synchronous, it doesn't matter what transport you're using, but if you wait for the result to come to proceed with your request, you're not there. So this kind of tower will fall if one of the things is missing. You can't take one out of it and everything will continue to work. It just won't. Okay, so far so good? Okay, let's continue. Now, so let's get to pro level number 5. You need to help them to choose a framework. Okay, it's one of the most important decisions that you can make for the team or can pursue to make the team. And what you can do is just to make sure that they choose a framework that doesn't do anything different, but it is reactive. How about that? So you actually you're satisfying both sides. Your teammates think they do reactive, and you're going to fail the project. The achievement is you just take the dinosaurs and put wheels on it. So it doesn't matter if the label performance is there. Performance, it's not the label. Performance is something that you can actually measure. And you actually can get to level of understanding what kind of architecture are you getting using the specific framework and what kind of scalability or distribution you get as well. So the idea of achievement in this case is you make sure that your teammates do not deviate even one single bit from the yesterday model of programming. They just stay there. Don't go anywhere. And I'm saying that enough is enough. We need to stop this madness, and when we evaluate the frameworks that potentially you want to use, you need to evaluate it not how simple or how fast you can run your hello world. It doesn't make any sense. You need to get back to the architecture and see how well it can be distributed, if it supports scalability and resilience that you want to achieve. And of course, there should be easiness of how you develop. But it comes with the rest. It cannot come alone. And I'm saying, try to see what Lagom is. I will try to pursue in the rest of time, and I'll get questions in the end. I would dare to claim that Lagom is different. Okay, but what Lagom is? As I said, it's not programming language. It is a framework for creating microservices-based systems. So once again, it might be very tiring to hear about popping so many different microservices-based frameworks nowadays, but I say Lagom is different, and I'll show you why. Now, the meaning of the word is just the right amount, and it is the idea that actually is of the framework. It doesn't do what it doesn't need to do, but it does very well what it should do. So let's talk about Lagom architecture. So the white boxes that you see right now on the screen, those are boxes that you can plug in, right? So API gateway, for example, it's not part of Lagom, but as architect, I would advise you to use API should you decide to develop microservices, just for sake of easier authentication, for example, and API orchestration. But let's take a closer look to apparently what kind of color it is. It's a color of Lagom. It's not red. It's not blue. What kind of, how it's called in English? Purple. Thank you. So it was supposed to be purple. So Lagom architecture from ground up is, first, it is distributed. Second, it is asynchronous. And third, it supports streaming. Not as something that comes as a foreign entity of the framework, but as something that actually is built in, and it's has very natural feeling, because when I'll show you how the service API looks like, how the service descriptors will look like, you can assume that the streaming will look more or less the same. So why can I claim that it is actually distributed and asynchronous? Let's take a look at the diagram. So we have services, right? The idea of the services are here, and of course we have multiple instances of those, no problem. Next come entity registry, and this one is the most important part in terms of the distributed. So when different services interact with the entity registry, this entity registry is actually something that is distributed by default. The entities can be distributed, and they will be distributed and sharded across different nodes. And the whole system is powered by different persistence plugins, which I advise you, we have several, but I would advise you, one of them is Cassandra, to use Cassandra, because it is actually gives you the better distribution. Now, I'm running a little bit ahead of myself. Anyone here heard about Akka? Oh, my people. So the idea of Lagom is actually a thin Java based layer on top of Akka cluster and Akka persistence. So anyone who heard, read, or was involved in project with Akka cluster and Akka persistence, what you see here, it's actually Akka persistence and Akka cluster. So the idea of Lagom is to take away a hassle of managing your Akka cluster and managing your kind of Akka persistence yourself and doing it microservices, opinionated way as we see it. Now, a little bit about message broker. So the idea, there are two main things that Lagom supports in terms of how data flows through the system. So the first, we have, of course, the persistent entities that we can create, update, query, and stuff like that. And we have actually events publishing. And the idea is that Lagom supports through its message broker API different message brokers. Right now it is Kafka, and but there are more plans in the future to use different message brokers. And the idea is that you actually, in a very easy and concise way, as we will see in code snippets in the next slides, you could do two things. You can create, update, query your entities, and of course give the concise results to a user through API gateway. And you can publish events so different services can know about different services. That's the idea how they communicate, because we don't want to communicate between them any sort of synchronous communication. It is the idea. Okay? There is no synchronous in Lagom. You can do it because after all it's Java, because you can actually enforce and just doing it not the right way. But the idea of Lagom is that you will have to make an additional effort to be synchronous. And if you want to go the easy way, you will actually remain asynchronous all the way. That's the idea. To lock into good patterns. Okay, so the main features. So the main features of Lagom, actually, we have 4. We have service API, that some of things that we, as developers, using Lagom will implement to support our microservices. Then there is persistent API, there is development environment, and production. Okay, so let's take a closer look at each one of them. So service API has been done in 3 steps. The first step is you have to declare your service descriptor. And service descriptor contains 2 things. It contains how you map your routes to the calls within your code. And optionally, if you decide to publish your data as it comes to the system, you can set the event publishing to a message broker. How it looks in real code. Okay, so the idea is here we have routes, API item, API item ID, API item, and then some kind of query string, and then there are calls. How the Lagom knows to map between request, response, and different query parameters, it knows according to the rules. And rules are very, very actually simple and very intuitive. So for example, let's take a look how intuitive they are. So for example, if I see update item, okay, where is my update item is, okay, I probably took it out. So let's take get item for a sec. Okay, so get item, it has service call, not used probably, it's an input. It's a request, and item is a response. What do you think? Get item will be mapped to post or to get? It will map to get because it doesn't have request. Okay? If something has a request, for example, create item, it will be mapped to post. If you don't want to mess up with the system, or if you don't want to have request but still to have post, you could also use method.post. So it's very, very rich. And of course, the mapping of, for example, of query string parameters or parameters within path are being handled by Lagom for you too. So you need to let start auction know that start auction, of course, I didn't take it. I tried to put concise code here. So for example, update item ID here, right? Update item is not here, but the idea is if update item was create item, it knows start auction, start auction. So this ID is going to be input into start auction. Okay, so get item for user, for example, that I was supposed to see from the beginning, we see ID, status, page number, page size. Those are guys that we see here. Okay, technical but very nice. Okay, and of course, we also setting up the event publishing if you want to, by publishing to topic. Okay, and item events that we will see further is just say letting the system know how to publish them if we want to convert the event to something else and stuff like that. Okay, so this was a descriptor. Step number 2. You, of course, need to implement the service so it will be functional. So there is 2 things that you need to do. First, you need to create the code for your API calls implementation. And second, you need to subscribe, if you need to subscribe to other services events and to operate upon them, it is the place to do. So how does it look? Okay, it's big enough. Very good. So, for example, get item, implementation for get item. For practically every call that you're gonna implement, there will be kind of stateful, which means that it needs to access the persistent entity registry to fetch something and then to operate on it because it needs ID. Maybe you don't, but usually you will have to. So the idea is that you fetch entity ref from the registry. It is asynchronous operation. Okay, what does it mean? It's actually the entity ref, you get it right away. Okay, and when you do ask, which is actually futures in Java, what you get back, it's a future that you can put callbacks as then apply. You don't have to, but should you decide that after you got the items that you asked for, you can put additional transformation or validation or what's not. It doesn't matter. But the idea is that everything is asynchronous, and ask returns the future that you can map to other things. Okay, I've omitted item events. It's because it's very technical. It's a couple of lines of code that actually sets up the topic producer and converting events. Should you decide not to save the same format as you have them as it comes, they come in, which might be really good idea. And of course, you have to inject to have the registry, the bidding service, for example. In case of item service, you want to have the bidding service because you probably want to know if auction was started regarding particular item. And item repository. So far, so good? Okay. So, subscribe to other services events. How does that work? The idea is, so you already have your bidding service, right? You have your bidding service in your code. You're calling bid service, you're subscribing, and then on each event that you're gonna get, you want to see, in our case, we want to see whether it's bid placed or bidding finished, right? If it's bid placed, I want to update the price of the item. And if it's bidding finished, I want to make sure that there is no more update prices can happen. That's the idea. Okay, once again, I omitted the code that actual application specific, but left the skeleton just to show how easy you can map from other services. Everything is asynchronous. It's event streaming from other service. Service API, step number 3, and the last one in this case, we need to bind descriptor and implementation, because implementation needs to know where this bidding service and entity registry to take from. So the things that we need to do, Lagom uses juice support, and the idea is that there is a configure method that you need to put how you bind between different things, right? It's very standard. Okay, let's talk a little bit about persistent API. So I know there's majority of you heard or dealt with Akka, which is great. I'm not going to ask you if you dealt in Java or Scala because it is a forbidden question in this conference. What I will ask though, have any of you used Akka persistence? Okay, not bad. So maybe I'll explain a little bit about Akka persistence. So Akka in this case, how Akka persistence works with Lagom. So the whole idea of Lagom is to take Akka persistence, which is a kind of implementation of SecureS, and to make it easier for digestion. And the idea is that when you have these entities, the different entities in Akka persistence, what you can do, the idea is that on every update that comes into the system for this particular entity, you can either change your state or it might be query. So you don't change your state, right? Or you can actually ignore it. Or you can decide if it's mutating the state, you can buffer it, or you can save after every command that comes in, right? So SecureS is, we have command, comes into the system, it's being persisted as event, and then the query side, the query actor within persistence, in the persistence we have write actor, we have read actor, the write actor persists events, and then read actor gets them and knows what to do. Now, in Lagom, it's even easier because what you can do, you can have your different states being described as a finite state machine. Okay? So let me go to class here in my online action Java. Now, this actual online action Java, is a repository that shows the greatest and latest of how to use Lagom, and is being maintained by Lagom team at Lightband, which all the kudos go there. So what we see here, we have item entity. Okay, so the item entity, it's where the magic of persistence from developer perspective happens. First, you need to implement initial behavior. The initial behavior, as we can see, it can have a couple of different states. Now, the idea is, if this item has not been created so far, it's the first time this item actually was created in a system, and underneath there is actor that represents this item has been brought up, it probably will be not created. But then, because might be the system was restarted, and it starts up, and it has some sort of state, it could be created, or auctioned, or completed, or cancelled, okay? Now, the most interesting part is, actually, you have a way, and we will get to the code once back in a second. The idea is you can put different handlers or create different behaviors and make sure that if item is in the state not created, the only things that it knows to do is to get item, because item is already there, just auction haven't started yet, or create auction on this item. So for example, is by any chance, because of the latency or whatever, not in non-created, but for example, in when auction happens, if there is command that does not correlate with the current state comes in, it won't be handled. Or if you want to handle it, you can handle it with an error. So as a finite state machine, we know from non-created, we want to go to created, from created to auction, from auction to cancelled maybe, or completed. Depends on the state. Within the created, we don't want to handle bidding price, because the bidding price has not started yet. Auction, probably bidding prices. After cancelled, we don't want to take bids anymore. So here is the idea. We have initial behavior, right? That's what we said. So for example, let's take a look at created. Behavior created. It knows how to handle get item, and the handler is set read only handler. It means that you don't have to you're not going to persist, right? And you don't have to specify what to persist. In set common handler, for example, it knows how to handle start auction. But there is no, for example, like in auction, there will be update price. So as long as we didn't put any update price here in the behavior which is created, it won't be handled. It will throw an error by default. You don't have to do a thing. You don't have to remember what not to do. You have to remember what to do. It's exactly the same. So, and of course, you need to set what kind of transition you want to have between different states. In our case, in case of auction started, we will go to auction. Which auction? It just changes to another behavior. In our case, our behavior will be, once again, we can get items, we can update price, and stuff like that. So far, so good? Okay, it's the hardest part that I probably explain the list in the list excellent manner. So you can have mutating or read only, finite state machine, and you can persist, but you don't have to should you decide that it is a query. And snapshots are built in, which means it's a partial reason why you have these different states when this entity has been spun up. Because maybe a snapshot took place and all the journal, all the events are not being replayed from the beginning, but maybe from some states that actually auction was already created for this entity. Stuff like that. So this is persistence, how persistence API looks like I showed. Now, a little bit more about Lagom before we go to development. So, first of all, I already mentioned that it's powered by Akka cluster and Akka persistence. Second, what makes it locking into good patterns is actually Java 8 lambdas. Everything, as you could see, is Java 8. Now, I would say it this way. Lagom, it's not Java 7 easy. Lagom is Java 8 easy. It means that if you have not embraced Java 8 yet, and you will start implementing Lagom, you will see, oh my God, what's going on here? And it's not because of Lagom, it's because of Java 8. So what I would advise, and I assume that everyone here knows and uses Java 8. Is it true? Don't be okay. Okay. So Lagom should be easy. Lagom should be easy for those, like this for those, and whoever didn't embrace Java 8 yet, it's about time because it's very important. Okay. Now, what else? Circuit breakers built in. It's not like you're going and you're fetching third-party library API and trying to stitch it. It's in. You don't see it even you don't have to configure it because there are sensitive defaults. But should you decide to configure it, you can. Okay. So the circuit breakers are in. Persistent layer. Currently, we have two. We have Cassandra, and after a serious enterprise pressure, we introduced GDPC support. We didn't want to, but we didn't have a choice. Cassandra is recommended for obvious reasons. As a message broker, we have Kafka. So in this case, actually, the pressure was positive. And we also have service discovery integrations built in, which are Console, Marathon, Kubernetes. It's actually SRV DNS, but Console, Marathon, and Kubernetes looked much more impressive than SRV DNS. Like, what is it? Okay, so let's continue to development environment. So first of all, if you go to online actions that I just showed, and you do git clone, and you do sbt run all, what will happen, even if you don't, actually doesn't matter if you have Kafka or you have Cassandra, because this thing doesn't use yours. It brings everything in. It doesn't need you to deploy anything on your local laptop. Everything bundled. No problem. Of course, when you go to production, you will start configuring things. But it's somewhere else, right? First, we need to evaluate. No external dependencies, and it's a real hot reload. It's not like hot reload from 5 years ago from GE containers. It's a real one. It means, for example, that if you run, I tried to kill it before. So if you do sbt run all, it will start Kafka, it will start Cassandra. Yeah, probably I'm using it somewhere else. No, it does not, it knows. Null pointer. Let's see. It works really well unless it is demo, but everyone says that. So let's see if it works. Please work. Yeah, it worked. Okay, so I can, for example, create a user. Obviously, I'm already in, so let's create. I met very nice guy last night. His name was Boris. He didn't understand why 1 a.m. and I'm working on something by not drinking my beer that stood by me for 40 minutes. He said that he's going to die. Okay, so Boris is there. Okay, so this is the idea. Okay, it works. Now, if I change something and I seriously try out yourself how deploy works, but the idea is if I change anything in my code, what will happen next? You will see hot reload here, and it will be hot reloaded. Okay. Yeah, I don't know what it is. Yeah, it's a jinx of demos. Now, let's get back on time. So, development environment, we said. Now, a couple of words about production environment. First of all, since it's a JVM application, you could use, and it uses both Maven or SBT. I'm more familiar, or more recently familiar with SBT. So for at least I would say that you can use SBT native packager, and you could create zip, RPM, MSI, what's not. And of course, with Maven, I'm sure that there are other tools that you can employ. So you can actually create your microservices artifacts and deploy them as you wish. Or you could use Lightband conductor, which is even more tighter integrated with Lagom, but it is commercial, I have to say. So the idea is that it's free for development or up to 3 nodes in production. And the idea of conductor is actually it's service orchestration, and it's manages, and it's scaling up, stuff like that. So it's kind of orchestration tool that you use on top of for example, or a side of console or Kubernetes or stuff like that. So this is the production, okay? Now, oh, it's the last one. So here is the thing. It is an active development. So there is a serious team of several very smart people who right now maintaining it, and as well as maintaining online auction Java that I showed you. Couple of things. Please check it out and try it. So there is lagomframework.com that you can read documentation and why and get know better the reactive microservices principles. Whoever is not familiar with Jonas Bonner, or they didn't read this free ebook by him, I would seriously advise you. I know what he says by my heart because I work kind of for him for some time already. But when I read this book, actually, it's pretty interesting because it's whoever doesn't know why Titanic sank, they will know after reading this book. And it's actually really interesting. I never thought. I thought that it's just because of the iceberg, but it's not only because of the iceberg. It's because of the isolation. But enough spoiling, you have to read it yourself. There is a Lagom forum, the Google forum that you can join and ask questions. There is a Gitter that you can use as well. It's very active. And the last but not the least, please git clone online auction Java, play with it, and choose by yourself whether it's something seriously reactive or just using labels to make themselves more attractive. Thank you. Questions now? No questions? I don't. Oh, yes, there are. Oof, yes. So I'm actually a Scala person as well. It took me some time to get back and get used to Java 8, but I took one for the team. And yes, the Scala API is coming. Actually, everything underneath. So if you click more than 2 clicks into underneath your API, you'll see Scala. So it is itself done by Scala, and Scala API is coming, of course, yes. But it was important to introduce Java API first because what we paid attention that actually whoever knows Scala usually can get by themselves with Akka persistence and Akka cluster. It's a Java developers who needs a little bit of holding hands. And that's why Java was the first. Sorry. No, it's if we could turn the business. So the question is if it was business-wise. Of course, it was a business goal. But if we could turn everyone to Scala, we probably would. But Java 8 is great. Java 8 solves all the problem, and business can go as usual, just with Lagom and being reactive. Anyone else? Okay, thank you.